What's up, guys? Getting things set up. 1 second. Whoa, 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 whoa. Oh man, what's up? Just give me 1 second. Gotta get my pages up. Yep, I got that up. Yeah. Okay. What's up, JP? Jacob? How you doing? I'm hanging in there, man. Hope you're doing all right. Mick said, okay, here we go. What's up, Mick? I know you like fish. I know you care. Whoa. LFS whenever. Whoa. And I'll be there. Whoa. You want some fish. You want some shrimp. But I can never be your fish and shrimp pimp. One buse for Landra. Girl, what you saying? $50 for 5 leaves. What are you saying? I ain't rich enough to swim into your heart. My first love tried to cycle a tank with quick start. And I was like, baby. No. What's up, people? How's it going? Whew. Maybe said, what the hell did I walk in on? You came into a congressional Congress of the fish room hearing. That's what you came in on. We're just presenting the evidence. Exhibit A. Sharp. How is it going? Yes, we're getting into fish egg fungus. It's supposed to be an educational stream. Gosh darn it. You know what I mean? It's supposed to be an educational stream. So, we're going to try and do some reading and stuff. We'll see what we can learn. I've loaded up some things. Yep. I got my things here. So, we'll get into it. We've been on a good streak of streaming pretty regularly, I would say. Hardest working fish stream in the chat. What's up, Maven? Sage Cave of Wonders. How's it going? Sorry about missing the other night. I just was not feeling up to it. I'm feeling tired tonight too. I was questioning, but I knew if I pushed it back another day that Mick would be so sad in the chat, man. I can't let Mick down, so I had to come back. Easy Smeeshi said, what's up? My second favorite subject behind brine shrimp. Oh my gosh, bro. This guy. I mean, you like what you like. Speaking of which, bro, when's the next 3 shades? I'm still waiting for you to set it up. Come on. Let's go. Mick said so true, Nick. It is true. But no, we're doing good. We got a good lineup of streams this week. I think I have a stream for tomorrow. And then I think I have a stream for Thursday. We may have Corey back on stream Thursday. Okay, so I every now and then people seem to indicate they enjoy having Corey on the stream. Well, if you enjoy having Corey on the stream, make that known, because that's what I'm trying to get done for Thursday. And then tomorrow, we'll see. I might cover a couple of news items. I don't know. We'll see what some things land. Let me know. I've thrown out Saturday twice. All right, let's rope Ross. You listening to this? We got to get Ross in on this. Maybe a Saturday. All right. So, fish egg fungus. Fish egg fungus. Oh man. JP says we need the stunted fish stream. Is that just about stunted fish in general? I'm trying to. I know there was like a specific thing with that. I'm trying to remember. Well, the thing is, tomorrow there was a kind of like this like outrage, this moral outrage on Reddit over Blackwater Aquatics that I kind of thought was a little bit silly. I was gonna go over tomorrow, but I was waiting to get some more information. JP said, Easy said that's a good topic about stunting fish. That's a good topic. There's a lot of cap around stunting fish. Oh, okay. Hey, if anyone feels like they're, knowledgeable about the subject, let me know. It's definitely not a bad one. Not a bad one at all. So, fish egg fungus is this thing, right? Everyone's got it. Everyone's got it. Everyone's got it. Okay, everyone's had it. It's just one of those fun things in life. But people have different levels of dealing with it. There's the people that do like alder cones. There's the people that just try and change the water. There's the people that just like whatever egg makes it is what makes it. And if you look up fish egg fungus, because it's one of those general things that does overlap with the aquaculture industry, so there's a lot of economic discussion and money that's centered around preventing eggs from fungusing. There's actually a lot of information about fish egg fungus, which is kind of nice. So, like here, you can see this kind of old page on the United States Department of Agriculture. They talk about fish egg fungus, and here's what they describe as the current hatchery's FDA-approved treatments. So, when you're treating stuff that might be used for human consumption, there's a bit of a higher bar around how safe it has to be, right? So it's a great place to start. So for instance, FDA approved for fungus on eggs, formalin and hydrogen peroxide is something that is used. Things that aren't approved or weren't approved at this time where they wrote this was copper sulfate, but they're working to get it approved. So you can see there's a lot of different options, but as hobbyists, we want to know what works best for us. Now, one of the classics is methylene blue. Okay, methylene blue is probably one of the most, like, if you're talking to an experienced fish keeper, what's more iconic than an old fish keeper in methylene blue? What, bare bottom tanks? I don't know. I just feel like it always comes up with them one way or another when it comes to fish eggs. JP says, when I saw boric acid, it made me think of borax powders or soap. Any relation? I think so. Or maybe not. No, it doesn't, maybe not. But it does sound the same. I think they're both borates. But this is a whole different rabbit hole we're going to have to go down over time here. First off, what's methylene blue? Because I kind of want to compare the two things. I kind of want to compare what the two things are. So, methylene blue, or more formally, according to this Wikipedia article, methylthonium chloride, which somehow sounds even more like an illicit drug. Methylthonium? Like, this is crazy. Common called methylene blue is a salt used as a dye and as a medication. Okay? It says all the medications it's previously used for treating cyanide and urinary tract infections, but this is no longer recommended. Okay. A dye. Well, you got to start out somewhere. You got to start out somewhere. Let me get down to the egg fact. I want to see if they talk about eggs. Yes, aquaculture. Used in aquaculture. Used against ick. Alright. Works against nitrite poisoning. Okay. Used to protect. Okay. Not known to have any side effects at correct dosages when it comes to fish. I've used peroxide. Maven said, "Yep." What's the difference between methylene blue and malachite green? You said Googling. Okay, I'll Google it too. I think, are they not both a dye? Let's look at malachite green. Yeah, it's also a dye. Now, if you want me to get into the compounds or stuff like that, I'm not going to do it because I don't understand it. But malachite green, that says refers to a chloride salt. Looks like methylene blue was some kind of other salt too, but they're both dyes, it looks like, which is a whole other thing. So then we have boric acid. Now, boric acid, I first heard about using it with fish eggs from Easy Smeezy in the chat. You know, the killifish people. We care a lot about eggs. They're some of the most dedicated niche of hobbyists when it comes to people who are constantly dealing with fish eggs up close and personal. And I was hearing rumors of this compound that you put it in the water and the fungus just doesn't exist anymore. You know what I mean? Methylene blue, it has its uses, it works, but, you know, allegedly there's some downsides, like maybe hardening some eggshells and stuff like that. I mean, plus it's like bro. I hate working with the methylene blue stuff as far as like like anything with a strong dye component. I'm always gonna get it everywhere. So the boric acid just sounded appealing because it sounded like a little bit less toxic, a little bit less messy. You know what I mean? They say you just put it in the water and it disappears. So I'm like, well, I gotta figure out what's going on with this boric acid stuff. But first, I want to go over methylene blue because I think we're gonna at the end of this think about I might be on team boric acid all the way because I have been using it and it seems to be working as advertised. So here we have our first reading for tonight, okay? And Andre says MG for ick considered harsher. Yeah, malachite green is what's in ICX, I think. TGI Fun Day. I said, hi, listening. What's up? Welcome, welcome. I know you popped in the other day for the first time. Welcome back. So, up in the chat, this is the link to the first thing I'm going to be reading through. But here we have the sterilization effect of methylene blue, formalin, and iodine on egg and adult stage of marine Medaka or Zyas densina, okay. Marine Medaka. Okay, this is an Indian rice fish. Okay, I am familiar with these. Yep, Indian rice fish, fantastic. I just used Riddick Plus on some live bearers. Yeah, I know some people that seem to really like that slightly more than ICX. They're pretty similar. They're both like formalin or formaldehyde and malachite green, I believe. Okay, so the sterilization of methylene blue, formalin, and iodine on the egg of Medaka were investigated for disinfecting a worm through sterilization, so through the adults and things like that. Which is another thing that's interesting, because you don't think much about like eggs being infested with worms or whatever, but here you see a Nadidae worm inhabiting on the egg of the Medaka, which is kind of terrifying. So they're looking at it for that purpose. But really, what we're looking for is Saplogynia. Yeah, this stuff. You ever seen this? This fungus thing? This is the main thing that we're worried about. Now, I didn't realize that this stuff could actually get on fish too, that it was the same. Like the fungus that can get on eggs is also like the fluffy stuff that can get on fish too. I didn't realize that was the case, honestly. But this is apparently what the boric acid just totally demolishes. Which does make me wonder if it could be used as a medication in these instances, but I have no idea. So the paper we're actually going to start off with, because I got my thing confused, is going to be the efficacy and safety of boric acid as a preventative treatment against sapropelagenia infection in Nile tilapia. So we're starting off with one that isn't even egg specific, but I'm hoping that it's just going to start off with our context on how this even functions, this even works. Okay. So, sapropelaginosis is a worldwide fungal-like infection affecting freshwater fish and their eggs. Reports show high mortalities and subsequent economic loss from infections. Most therapeutics are inefficient, and some have negative impact on the environment. In this study, we've investigated the ability of boric acid to prevent sapropelagenia infection in Nile tilapia. Okay, so let's look at their methods here. Here we have some figures of fish infected with it. You can see quite fuzzy, quite disgusting. These are tilapia experimentally infected with S. parasitica, showing severe black squares and moderate white squares showing signs of infection in non-treated control group. That's A and B, while C is showing signs of mild infection. Yeah, experimentally infected. You gotta love to be a fish in these instances. Bear with me, because I'm still getting my head together right now. All right. So here they tested different concentrations. They have recorded fish mortalities following 96 hours continuous exposure to boric acid concentrations, different concentrations, and the mortality rates differed with the boric acid concentration. So they had 20%, 75%, 100%. I'm having a very difficult time reading tonight, I'm gonna be honest. Okay. Cumulative mortality and severity of lesions following in vivo infection with S. parasitica and the effect of boric acid as a preventative treatment against infestation over the 10-day period are shown in Table 2 and 4, Figure 4. Okay, let's go to Table 2. Let's see what's going on here. All right, percent survival is over here, the vertical, and on the horizontal we have the days post challenge. Okay, and this is the different concentrations of boric acid. So the black circles is like the lowest, and then the red is the highest percentage from 0 to 0.8 G/L. And you can see the higher the concentration of boric acid does seem to significantly improve the survival rate. So the lowest after 10 days, the one with no boric acid in the treatment, it looks like 38% survival rate. God, that's terrible. Then we have the highest concentration at 10 days. There was, or it looks like around like a 85-90% survival rate. That's, man, you hate to be picked for the wrong group in this, huh? Okay. So this is as a medication. Fantastic. All right. Let's go to the eggs. I'm going to the next one. And hopefully I can wake up a little bit. Next. Mick said, that's the way of the human world today. Wouldn't have all the meds and if we had not done different tests similar to that one, I suppose. Yep. What you gonna do? What you gonna do? All right, boric acid inhibits germination and colonization of Sapogenea spores in vitro and in vivo. All right, we got an ethics statement. Okay, come on. I didn't remember an ethics statement from before. Let's go. According to Norwegian regulations on animal experimentation, no special permissions were required for eyed eggs or yolk sac fry experiments. Okay. Okay, chemicals. Boric acid H3BO3 was used as a source for borate to test its effect on the germination of the Sapogenea spores and the growth of Sapogenea hyphae in vitro. Boric acid was also tested for the control of Sapogenea infection of eyed salmon eggs and yolk sac fry. All right, let's go. Jacob said, "Setting up my microscope. Right now I'm going crazy with microbiology. I love these kind of research studies." Well, hopefully they show us something. Hopefully they show us something. So, effect of boric acid on germination and colonization of Sapogenea spores. Sesame seeds were autoclaved at 121 degrees Celsius for 20 minutes and cooled. Sapogenea zoospores were then produced according to the method previously described by Stuland et al. 2005. 400 UL Sapogenea spore suspension. Okay, they infect some sesame seeds. Sterilized aquarium with some water. Sterilized aquarium water was used as a non-treated control, and Bronopol was used as a positive control. Each boric acid concentration controls were tested in triplicates and incubated at 20 degrees Celsius 24 hours later. Plates were examined microscopically. The germination and colonization of Sapogenea spores on sesame seeds were graded as follows. So we're starting on some sesame seeds before we even get to the eggs. So grade 1 is no germination, no growing mycelia on the sesame seeds. Grade 2 is germinating spores, no growing mycelia or on the sesame seeds. Grade 2 is germinating spores, very few growing mycelia on the sesame seeds. And grade 3 is germinating spores, profuse mycelia on the sesame seeds. Okay, they were incubated with the sterile sesame seeds using flat bottom microwell plates for 12 hours at 20 degrees Celsius. Let me see. What does this plate look like? All right, one of these. Oh, okay. Yeah. Yeah, this looks very science. I'm into it. Okay, science. Let's go. Whew. The plates were observed microscopically to confirm the attachment of the spores to the sesame seeds and the presence of the early growing mycelia. Boric acid was added at 12 hours post-infection of the sesame seeds at the same concentrations mentioned above to all tested plates except controls. Plates were further incubated at 20 degrees Celsius. SAW was used to non-control and Bronopol as positive control. Plates were inspected after 24 hours for advanced mycelial growth. Mycelial growth on the sesame seeds was graded for 0 for a complete inhibition of growth and grade 1 for slight reduction on the growth or the presence of abundance of the growing mycelium on the seeds. All right. Sesame seeds growing with 24-hour growing hyphae were incubated with different boric acid concentrations. Yep. And examined later. All right. Let's see what the results were. So here we have the results from the sesame seed test before we even get to the eggs with the boric acid. So over here we have A1. Okay. A1 and A2. This is grade 3. So this they call this profuse. Yeah, I'd have to agree. Profuse Sapogenea hyphal growth on the sesame seeds in the non-treated control water. So here we got the control up here. They call this profuse growth. I'm gonna have to agree. B1 and B2, they call this grade 3 germinating spores with mycelia growth on the sesame seeds. It's not profuse, but you can see a little fuzzies there. Nick said Nick's influence is second to none. I don't know about all that. My bad influence. Okay. C1 and C2, grade 2, reduced germination and minimal mycelia growth. So this was at boric acid 0.2 to 0.4 GL/L gram a liter, I believe. And the one before, that was C1 and C2, B1 and B2, I think that was less than 0.2. So then our first grade 1 comes with 0.5 to 0.7 grams a liter boric acid. And that's E1 and that's D1 and D2, my apologies. So I can't really see much, but I guess in this microscopic, super microscopic zoom in, they saw a little bit. Germinating spores without growing mycelia on the sesame seed. So germinating but not growing mycelia. And then E1 and E2 is grade 0. Nothing, no growing. And this is at 0.8 grams of boric acid liter. And then positive control group with bronopol, no spore germination with absence of growing on sesame seeds. Fishy and Jay said nerdy stream today. If I can read, yes. What's up? How's it going? We're talking about the effect of boric acid. We're going to try and compare boric acid to methylene blue when it comes to fighting fungus on fish eggs. Fighting fungus, fish eggs. Fighting fungus, fish eggs. Fighting fungus, fish eggs. Fighting fungus, fish eggs. Okay. Here's the Saprolegenia strains they use for in vivo testing. S. declinia, VIO 2739, and S. parasitica, VIO 2741, were used for in vivo testing. Both strains had previously been proved to be pathogenic for salmon eggs. Cysts were produced according to the method described earlier. And the origin and treatment of the eggs used, they used Atlantic salmon-eyed eggs, Aquagen strain, with the following criteria: 385 degrees days post-fertilization at shipment. All batches of eggs were formalin treated as a standard procedure during incubation and disinfected with bufadine before shipment. Temperature range during incubation was 2.4 to 8.0 Celsius, average 4.2 degrees Celsius. The parent population has been screened for infection with salmon pancreas disease virus. Damn, they put a lot of effort into this. Infectious salmon anemia virus, and for Rhinobacteria salmonarium, causing bacterial kidney disease. After arriving to the laboratory aquaria at the Norwegian Veterinary Institute, eggs were transferred to an incubator, which was supplied with continuous water flow, 0.8 liters a minute per liter of eggs, with water temperatures ranging from 5 to 7 degrees Celsius. To avoid mortality from transportation damage, eggs were acclimatized for 3 days before they were used in the experiment. Groups of live-eyed salmon eggs were killed by immersion for 1 minute in a water bath at a temperature of 60 degrees Celsius. Holy. What's up, Johnny Best? How's it going? How's it going? Yo, Johnny's going to be... Thursday we might have his favorite person on the stream. Holy. Dead eggs were incubated in a 24-well micro-well plate with Saprolegenia spore suspensions. Incubated eggs were examined microscopically for the presence of Saprolegenia hyphae. 3 different challenge experiments were performed on salmon eggs and 1 on salmonoid yolk sac fry obtained from the hatched eggs as described. In this experiment, we aimed to test the safety of continuous exposure of live eggs to different concentrations of boric acid and to test the activity of boric acid with regard to its ability to control the spread of Saprolegenia infection between eyed salmon eggs. The setup allowed us to determine the optimal boric acid concentration, which is safe for eyed eggs, and at the same time able to control the spread of infection between eggs. And Johnny Best dropping in with $5 right after he hops in the chat. Appreciate you very much, Johnny Best. Johnny Best in the chat. Holy. Johnny. Thank you very much, my friend. hopefully, I'm hoping to do a stream with Corey Thursday, Johnny. So be around. You claim that's the only time you ever learn on stream, so. All right. So about 730 live eggs were used in the experiment, divided into 9 main groups, and tested in 7 different boric acid concentrations. Easy Smeezy said, just started paying attention. That's 1 for everyone keeping track. Oh my god. Plus 2 controls as described below. Each group were divided into 3 replicates of 27 plus 2 eggs. Live eggs were challenged by co-incubation with infected dead ones. So they put live eggs with some dead eggs that are going to fungus over. They're trying to see which concentration of boric acid protects the eggs that are still viable. Eggs were placed in a container to form an even layer, a 1-egg layer, and to be in close contact with the source of infection. To control the incubation temperature, all the containers with different boric acid concentrations tested, and the controls were kept in water bath with continuous water flow. Each container was supplied with an aerator. Water temperature during the experimental period ranged from 4 to 7 degrees Celsius. The pH ranged from 6.8 to 7.0. Now, I think one thing that is nice reading these, even when I don't understand half of what they're talking about and setting up the experiment, is it does give you a good idea when you can tell that a paper has some budget behind it, how much effort they go to control as many variables as possible. They've detailed where they got the eggs. They've detailed the genetics of the salmon they got it from, the diseases they tested it from, the strains, the specific strains of fungus they're testing. Like, I think it's nice to show some appreciation to like how much effort goes into trying to conduct an experiment that has results that are meaningful, that you can actually learn something from. I do take inspiration, and also I will probably never put this much effort into anything, but I can appreciate it. All right. In all treated groups, eggs were exposed to boric acid continuously until most of the eggs were hatched. Boric acid treatment was tested at the following concentrations. So there's 7 concentrations, I think that's gram slash liter, gram per liter. 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, and 1.4 is our different concentrations. Eggs incubated in aquarium water were used as non-treated negative controls, and those exposed to bronopol served as positive controls. I'm just going to look up bronopol. Okay, yeah. That's a highly effective broad-spectrum antimicrobial agent used as a preservative in cosmetics, blah, blah. Okay, so their control is just putting the eggs in like a extreme antimicrobial thing as a control. Okay. Eggs were examined every day for attachment between the dead infected eggs and the live ones, presence of any dead eggs, time of egg hatching, hatching rate, and the presence of any yolk sac fry abnormalities as described by Thone et al. 2011. So this is continuous exposure. They also tested intermittent exposure to boric acid. So there's a couple different experiments going on that we gotta keep track of. So that's the setup for the continuous exposure one. Intermittent exposure, the experimental design was as described in experiment 1 that we just went through, with the same number of eggs per replicate, and the number of infected eggs included per replicate, 3 per 27 eggs. So just remember, for each experiment they're running with different concentrations, there's 3 replicates of each one. Okay, so it's not like they just set it up. Okay, this one's 1.2. They got 3 replicates per 27 eggs. Have you heard of a solution called FMC? It's both meth blue and malachite green with formalin. I'm not familiar, but that does sound terrifying. As far as that's a lot all at once. I don't know. I have to look into that. Remind me about that sometime. I'll write it in my notes. My notes aren't here. 1 second. FMC. Alright. I'll look into that. Okay. The only difference is that the eggs were exposed to higher boric acid concentrations. So this experiment, they're testing how intermittent exposure instead of continuous is. And instead of starting at 0.2 like they did in the last one, they just went straight to 1 gram, 2, 3, and 4 as their boric acid concentrations. So intermittent exposure, but higher concentrations. And they did it for 4 hours once a day over the course of the experiment, which lasted 14 days in total. After 4 hours of treatment, the flow of aquarium water was resumed. The same treatment was applied 24 hours later and every day up to 14 days. The time between treatments was the same throughout the experiment. The number of dead eggs, presence or absence of infection, and hatching rates were recorded over the duration of the experiment. And infected dead eggs that were used as a source of infection in the boric acid treated groups and non-treated control were examined microscopically to observe the effect of boric acid treatment on the growing mycelia on the dead eggs. Okay. Protection against infection of dead eggs. So we see some, this is another experiment here. This is to investigate the ability of boric acid to protect dead eggs from becoming infected with the spores. So we have one experiment that's set up that's just to see how continuous exposure protects the eggs. We got a second experiment that's set up just to determine how intermittent exposure affects the eggs. And now we're going all the way to, can boric acid prevent dead eggs themselves from being infected? Yo, we got the PhD, 5 PhD certified aquascaper trademark and copyright pending Bomba. Sergi in the chat. What is up? I'm late to the party, holy. What's up? What's up? We're just talking about some fungus, man. So for this, 5 egg groups were used, divided into 3 smaller groups. 25 live eggs plus 5 dead ones were placed into each subgroup, 90 eggs per group. Dead eggs were prepared as described above. Continuous water. The aquarium water at the facilities of the Norwegian Veterinary Institute contained Saprosilenia zoospores and was used as a source of infection. See, that's another thing of why I started thinking about putting a UV sterilizer in the water as it comes out of my tap. Is like the spores, all this shit is like, a lot of it's like in the damn water, man. He said, Bamba said, no boost? No boost today. No boost today. Well, I'm looking around. Where's the boost? I want the boost. Give me the boost. I don't think I got any boost. I got no boost. I just got Galaris fry. All right. So they got the spores in the water. Yeah, that's one thing I've been thinking about is, well, if I got the spores in my water, I do a water change, and like, what if I have a problem with this? Like that, we're already starting in a bad place. Like I kind of want to put a UV sterilizer on my water coming out of the tap. It's kind of something, an interesting thing I want to do. But first, I need to put a carbon block on there, honestly. All right. So we got the water, seeing if it can protect the dead eggs. They used concentrations of 1, 2, 3, and 4 G/L, so the same as the intermittent one. Was 4 hours a day, after which water resumed. Dead eggs were expected daily, and this lasted for 14 days as well. Bomba said, anyone else's licorice gouramis hide all day. Bomba, put the species you got in the chat. Bomba got some really cool licorice gouramis. I'm not gonna lie. They're very cool. They're very, very cool. But it's only been a few days. All right, and then they tested protection against natural infection and yolk sac fry. So this was to test the safety of continuous exposure of salmon yolk sac fry. Now, this is pretty relevant because I think one of the things with methylene blue is, I believe, correct me, but I believe people try to avoid having a bunch of methylene blue in there when the eggs actually hatch. So I think it is bad for newly hatched fry, if I remember correctly. Everyone roasting Baba in the chat already. Easy Shweezy said, if you dropped them in one of your pristine aquascape tanks, I would not be surprised. A couple fish says, buys shy ass fish, wonders why they're shy. He used to be a video of them tearing up some food. They didn't look that shy. I say keep feeding them and sitting there while they feed. Oh, Ben says, "Can I have a free fish tank?" Yes, Ben. Yes, I got one for you actually. Check it out. Check it out. It's rimless, acrylic. I believe dishwasher and microwave safe as well. Just let me know. I'll put it in the mail. Get the free fish tank over to you. Mick says, you need to imitate nature, Bamba. Licorice Garami live in very special waters and creeks. JP Jeffers says they hate the skate Bamba. The tank he put him in looks very, like one that would be very nice for them. He put a bunch of seed pods in there and stuff. I mean, it looks great. That's my opinion. You know, everything art is subjective, right? So maybe my opinion's wrong. Who knows? So they got 330 yolk sac fry of Atlantic salmon obtained from treated hatch eggs, divided into 2 equal groups. One was kept in aquarium water, naturally containing virulent Saprolegnia spores. Group 2 was put on a continuous treatment with boric acid at a concentration of 0.5 grams a liter. The containers were supplied with air through air pumps. How else? Yolk sac fry were observed daily, and the numbers of dead yolk sac fry per day were recorded in groups. Honestly, I never thought about, like, for instance, like corridors. I never thought about, like, fry, their mortality rates, and that being tied to the fry themselves being infected with this, but it kind of makes sense. Bamba says, if Nick likes it, it's definitely ass. Palm Puppy says, Ikex does not have methylene blue as methanol. I believe, yeah, Ikex is formaldehyde, 5%, methanol 2%, and malachite green chloride 0.1%. So basically formalin, methanol, and malachite green. But it is very blue. To confirm whether the high mortality rates were due to Saprolegnia infection, live and freshly dead yolk sac were collected and examined from both groups in the experiment, examined microscopically and incubated on glucose yeast agar with antibiotics. Plates were, so it's like even checking, like, okay, the fry died, let's make sure it was actually because of the thing we're testing for. So putting a lot of work in this. Mick says, I have some licorice Garami too, put in a tank with a lot of moss, beech leaves, wood, etc. He needs to put the species he got in the chat, because I think of the species he got is particularly cool. They look very brolic. Okay, so here we have the sesame seeds, which we already took a look at. Here we have the Saprolegnia cyst germination. And this is on the different concentrations. So it looks like by 0.6, there's almost there's not even 5% or barely 5% mean cyst germination from S. parasitica. Now S. declina seems like it's a bit harder to kill. So we got 2 columns on this chart. One is S. parasitica and one's S. declina. But at 0.8, both S. declina and S. parasitica just go completely to 0. Like at 0.7 to 0.6, S. parasitica is like pretty much, I would consider to be negligible. But at 0.8 grams a liter, it's almost completely gone. So like, very effective. The effective boric acid on the Saprolegnia radial growth rate by about 0.5, it's pretty much gone on both strains of Saprolegnia they tested. And yeah, again, 0.6, there's like barely any, and by 0.7, it's gone. So right now I'm like, okay, 0.8 grams a liter. Seems like that's probably safe so far from what we've seen. Okay, so now we get to boric acid arrests formation and development of Saprolegnia zoosporangia. So they assessed the impact of the boric acid on the development of sporangia and the maturation of Saprolegnia zoosporangia. And they found that boric acid just straight up arrests the formation at 0.4 grams a liter, and interferes with the production and the subsequent release of zoospores at 1.0 grams a liter, which is exactly what Aaron told me. I think he said a gram a liter, maybe, or something like that. It was a gallon, I think, 3 gallons. Anyways, the point is the promise of it was basically you put it in the water and it just completely inhibits the growth. I put a bunch of eggs in a new tray. They all fungused over. I put some boric acid in, and all the fungus on the dead eggs went away. You know what I mean? That was like my first time I tested it. After that, I just started sprinkling in egg trays, and definitely, like, if there's a dead egg, even the dead eggs don't fungus over. So I still need to actually do better of actually measuring how much. I converted to gallons, 3 grams a gallon. It's amazing. Yeah. Mix I recommend aldercone, but add slowly, no quick change. I think that's the Bomba. Sergi says it's a UNS 60S with lava rock and dragonwood, Monte Carlo and Boost, and Anubias high-tech CO2. They seem to come out when the light dims in the evening. And the species that Bomba got is ornitocata. It's very. I'll show you this. Licorice gourami ornitocata. I might have to pick up some of these myself. Yeah, it's this one. Sorry, let me copy the whole name. I didn't feel like trying to spell Paris famous, but this is the one that he got. They had a bunch of them, so I'm gonna have to go back and get some before they sell them all, cause it looks pretty dope. Bomba said, "Pull the vid I sent you. Did you send me another one recently? I'm about to check it out." Okay. Then they went on to assess. They found that it arrested development of 1.0 grams a liter. Vacuolation of the entire of zoo sporangia was the most prominent sign observed after treatment. I'm gonna look up that word, vacuolation. Or vacuolization, the formation of empty or fluid-filled cavities within or adjacent to cells, often indicating early degeneration, cellular stress, or injury. Okay, just blowing them up. Aaron said, "Oh, these are the good ones." Yeah, I think he got 6, and I think they said they had 60. This is London Town Tropicals. I'll pull up the video that Bomba sent me in a second. I gotta find it. Okay, so. Here we have, I gotta get the PNG for a bigger image here. So we have S. parasitica and S. declina, and we have the mean sporangia number per field on the left, and then on the bottom we have time following induction. Okay, and we see after 12 hours, it seems that's. Okay, we're seeing how much it is after 12 hours. And this is with different concentrations. I forgot to point that out. So after 12 hours, we have the lines with different shapes. Is how we tell which concentration. And it looks like at 0.4, it seems like there's basically nothing after 12 hours. At 0.0, we got like around 20-ish%. At 0.1, there's like 10% mean sporangia. At 0.2, there's like 8% after 12 hours. And then at 0.3 and 0.4, there's like 5% or less. Mix that I meant aldercones for the licorice gouramis. Yep, that's what I figured. Mix that. I guess they have lots of predators in the. I gotta pull up the. Send me the video again so it's at the top of my thing, Bomba, because I'm being lazy. But they look so beta-like in the video it's sent. I gotta show you guys. You'll appreciate it. Okay. In vitro effect of boric acid on development of Saprolegnia spores. I just sent it on Discord. All right. Let's see. Wait, quick break. We're gonna look at fish for a second. I know you guys are just gonna be so disappointed. that we're looking at fish, but really. How do I make this? Okay. I see what we're gonna do here. We're gonna make this impossible. Okay, let me open up this video. And now I got a video to play. So here we see the tank where Bomba's put the fancy licorice gourami in. Now look at them, man. Look at them attacking that. What was that? They just look so... I don't know. I have a Linky. Like the Moonlight. This looks like two males. I don't know, getting kind of active. But they just look so strong. Look how they just knocked that entire seed over. Oh my gosh. But they remind me very much of my album Marginata. Very Beta-like. Okay, let me play one more. I got one more video. Beto said savage. What's up, Beto? How's it going? Yeah. No, I thought you guys would appreciate this because it's a rare fish. You know what I mean? Rare fish. That's what we like around here. Rare fish. Which video is it that I already played? Ah, here we go. Yo, it's so fun. This next one, you see like crystal shrimp running around. This is so funny. Okay. Let me pull this up. Mick said the peat from marshland or bogland or cloudberries thrive is a perfect hiding space. I see. But here we see some, we see more of the tank that he put them in here. So it's very aquascaped, very fancy. And we see a couple of them. He's got some chili reservoirs in there. And yeah, dashing across. I mean, they got a whole wonderland to hide in back there. But give them some time. Give them some time. All right, back to some fish fungus. This is the real stuff, okay? This is the real stuff. Who cares about fish when you can, you know, look at eggs fungusing on a graph? Okay. This is the in vitro effect of boric acid on the development. So A1 is the non-treated control before and after. A2 is the spore release. Then in B1 is after 24 hours of exposure to boric acid. And B2, it says notice the degenerative changes within the zoosporangia in the absence of spore production and release. Like, I'm gonna have to take your word for it, but I do see the kind of the pitting in this little cellular thing here. It does look like it's degrading. Beto says, I got a bunch of otter cones now, but the quarries aren't putting eggs. And Andre says, gorgeous tank. Yeah, maybe we'll have to do a call with Bomba. We need him to feed the licorice gourami and show us the tank after we're done reading about boric acid. Oh, man. I wanted to do a rating your tank with Bomba thing again. Maybe that's what I should do tomorrow. Would you guys submit photos of your tanks to be reviewed? Bomba said lights are off. Okay, whatever. Photo period. Nerd. So post-treatment spore release is dependent on length of exposure to boric acid. Having shown that boric acid arrests the development of zoosporangia, it is our interest to test if treated, zoosporangia would release spores after treatment was terminated, and we tested different exposure times to boric acid. Andre said, tank competition? Well, I don't know competition, but I would like to do a stream soon again. We've done it before. People submit their photos, and we evaluate. Just, fun little thing. Okay, some sporangia that were treated with boric acid for 12 hours and 24 hours showed spore release after 24 hours after exposure had been terminated. In contrast, in samples exposed to boric acid for 72 and 96 hours, no spore release was shown. Massive spore release was recorded in the non-treated control group. Figure 6, we see viability of treated sporulina spores and zoosporangia during treatment and post-treatment removal. And I gotta get the larger image here so we can see. Beto said, I'm gonna omit my swamp tank scape. Oh my god, bro. So A1, A2, we got non-treated water control. So these eggs are just totally boned. They're dead. Or this, the spores everywhere. During treatment, okay, looking clean. 1 day following treatment, you can see a little bit of active. 24 hours after treatment, see a little activity. 1 day following 96 hours of treatment, we're seeing like nothing though. So treated for long enough exposure seems like it has a lasting effect. Bamba said Discus North will not approve. Man, that shit was so funny. I'm waiting for Mexicali to rage bait more. You know what I mean? Like, he's got it in the palm of his hands. As soon as Swim Deanna decides to instigate again, like, we might get the debate. He might just pop out with a swamp tank. Maybe he'll just pull up to Father Fish and have Father Fish dump like 3 gallons of bat guano right into his tank and just live stream it all. And we'll just see Discus North. There'll just be a scream from his home in Canada. And everyone in the North will hear it. Welcome to the North. I've never met someone more fit to be a fish tube evil villain. Listen, I seen him pop out on. He went on Salient. Was that his? That was his move afterwards. Let's see, Salient Aquatics. Is that what I saw? Yeah, man. We got. Why is there 2? Oh, okay. Salient's doing the same thing that Fishery's been doing, right? You stream a vertical and a horizontal at the same time. Should I try doing that, or should I just? I don't know. I feel like I don't want the vertical people. I'll be honest. I feel like I don't want the vertical people on my stream. I like the horizontal folks. Come on, let's get some more tribalism. Yeah, 280. Yeah, listen. This is not good enough. This is not good enough. We need more instigation. Come on, 9 likes on both. I thought Discus North had more pull. Come on, man. Can we ride the entertainment wave? Like, can we not make some hay out of this, guys? Let's keep the drama going. Where's the Aquafunk and Discus North debate? I thought we were finally going to have some free entertainment, man. We could watch a live lovers quarrel. Well, okay. Back to the paper. My bad. I got distracted. You might get more bins in the chat with a vertical. Oh my god. Better said F for real, but wanted to get a UV sterilizer because of Discus North. Porg fish keepers. We will be baptized on YouTube shorts just like Father Fish does swap takes. That's hilarious. You want him in your house? No. Wait, Vic said I just want Discus North himself in my home, lighten up the plate. Wait, what? Pause. What do you talk about, Vic? Why you want him in your home? So I have a UV thing I tried to hook up in line with my canister, which I think is when it's most worth it. The thing with it is just, there's a couple things with it. One, it can't do anything about stuff that's on the surfaces in your aquarium. So like, it's my understanding a lot of mycobacterium and stuff like that, can hide in the surfaces in your aquarium and stuff like that. The UV's only really sterilizing what comes through it. Then you got to have it at a high enough strength, and the flow's got to be at the right speed where it actually has enough time to kill what's ever in the water. So I think it's overall, it's good. It's a lot. It's adds more power it's using. I mean, there's not really that much bad about it in my opinion. But it can only do so much, right? It can only sterilize things that are going through it. So there's no perfect. You just got to keep adding things. I don't think it's really necessary for most people. But like I said, I've been wanting to put UV on the stuff coming from my tap. You know what I mean? So then doing a water change maybe is more meaningful, because instead of putting water in that already has whatever my tap water has in it, then I'll be taking out water and putting in, water that doesn't have anything in it. A smart person said UV probably helped when my main setup had a huge green water issue. After that, I went to the closet. Yeah, I think having even just a less powerful UV thing, if you just want an easy way to deal with green water, I mean, it works pretty well for that. Yeah, I mean, I think UV is cool. Again, these are all things. If you have less aquariums, I think these are things that are more worth talking about. You know what I mean? To make it worth it to have I need basically like a canister system I can move from tank to tank with UV on it just every now and then. Like, let me do a sterilization of this tank for the next, week or something like that. Smart person says supposedly most of our tap water says copepods sometimes. Yeah, and like here in this test, they just said the Saprogenia spores are in our water. So that's why I'm kind of thinking, depending on what water you have, you put your eggs in some tap water, maybe you will have a. Does UV in the all-in-one still working? I haven't been using. I haven't been using the UV in the all-in-one, but I mean it would work. The thing with the UV is just power, and then how long it has, like how slow the water's going through, where they can actually sterilize it quick enough, and different things. Like it's gonna take a different amount of power to kill, some protozoan in a certain life stage compared to some bacteria. You know what I mean? Mick says, yep, UV is used for oyster spray bars for restaurants. Of course, Mick knows that. Of course. Spreading that peaceful aura in your room? In your house? Okay, Mick. That's good. He never gets upset, so be calming. Okay, fluorescence microscopy showed the viability of boric acid treated Saprogenia spores and zoosporangia. Colonization is seen under control. Okay, so it's kind of explaining what we just looked at. Yep. I'm waiting for the part where it tells us the downsides, but so far it just seems like easy peasy, lemon squeezy. Okay, this is the extent of which continuous treatment would prevent infection of fertilized eggs. We used a co-incubation method where live eggs were challenged by introducing killed and experimentally infected dead into the tray. I just think it's so funny how we killed the eggs. Like, oh my god, man. Serge Bomba said Discus North doesn't know how UV works. You haven't watched his videos, you don't know. In the non-treated controls, and 3 days after introduction of the infected dead egg, the hyphae started growing out from the infected dead egg and colonized the surrounding live eggs. In the boric acid treated groups, no colonization was observed. On day 5 post-challenge, eggs in the non-treated group started to coalesce and formed a 1-unit appearance of dead eggs completely covered with Saprogenia mycelium. Still no sign of infection was observed in the treated groups, and no dead eggs were observed. In the group treated with boric acid at 0.2 grams a liter, one infection focus was found with slight attachment between 2 live eggs and infected dead eggs. On day 7 post-challenge, eggs started to hatch in the non-treated group and some of the treated groups. 0.4, the eggs in the groups treated at concentrations 0.2, 0.6, 0.8, 1.0, and 1.4 gallons a liter. Hatching started 1 day later. Smart person says, yeah, he thinks it works like Iron Man's hand raise. Wait. Bramba said, bro, he blinded his fish. UV lamp inside the tank. Jesus Christ. He thinks it works. UV, you don't want to run a UV lamp where you're like looking at it. It's shining on you too, right? Like, this is why you can't. This is why I hate channels like. I hate fish channels that spread so much bad information is so avoidable. Like the Luke Scoldy thing where he blinds himself with the UV lamp. For all we know, it was like it was a stunt. It was fake, you know, for some views. Because that brine shrimp hatching thing where he froze the brine shrimp, I'm pretty sure it was rage bait. It's one of the dumbest things I've ever seen in my life. I just hate channels like that. So yeah, anyone that's going to be showing people just an open UV lamp in their fish tank, like you can't possibly ever listen to someone like that. Like, it's just unsafe. You know what I mean? Like, it's just if someone shows you that they're that careless and they don't seem that concerned about it, it's best not. You probably should just question everything they say just a little bit. You know what I mean? Like, do a little bit of research. You know, just a little bit. Yeah, Mick said, read instruction carefully before using UV. Smart person said UVC is blinding, correct. Jacob said, that's how you get cancer. And Bomba said, that's why it's always enclosed or in line. Yeah, don't use any UV lights that are just out in the open. It should be inside of something. Oh my God. Okay, still no sign of infection was... Okay, I read that. Results obtained during the second week were similar to what was during the first week. No infection was recorded in any of the concentrations tested except for 0.2 gallons a liter of boric acid. At this concentration, slight attachment was observed between the eggshell, the live eggs, and the infected dead egg, but this did not cause the fetus to die as eggs hatched and yolk sac fry swam away from the eggshell. I don't know if you've ever seen an egg like slightly fungus, but like the egg hatches quickly enough and it's not a big deal, like that kind of a situation. Mick said, if I remember correctly, there are UVA, UVB, and UVC rays, different effects for and on living tissues. Oh, different living tissues. Oh, fantastic. Fantastic. Well, let's get the full spectrum going. At the end of the experiment, in groups treated at boric acid concentrations less than 0.2 grams a liter, the mycelium covering the eggs were used as a source of, was used as a source of infection was scant, while many infected dead eggs were detected in the non-controlled treatment group. The percent of dead and hatched eggs were recorded after the termination of the experiment. The Bronopol treated group showed positive control showed 100% mortality after 4 hours continuous exposure. So here we see the effect of boric acid treatment on salmon egg used as an infection source. The A is the non-controlled treated group compared to the treated one that's exposed continuously. So here you see this the one that has no treatment. We got plenty of hairs, and then over here, this one's almost as smooth as Discus North's head. Let's go. Honestly, we should have Discus North and Aquafunction should have a head off. Pause. I'll leave that there. Mick said, I have used the enclosed ones 20 years ago. Bomba said, apparently the new Chihiro's Vivid Pro has UV inside the light to mimic the sun. Great. Let's add the... We need to put that cancer back in light. That's what it's been missing. So here's the continuous exposure to boric acid group and the hatching rates. So mortality and hatching rates in the boric acid treated groups in the non-control. The checkered line we have hatched, and then the black we have dead. And on the vertical axis we have dead / hatched eggs. On the bottom we have the boric acid concentrations. So it looks like at 0 boric acid, about 35% of the eggs were dead, and then the rest hatched. At 0.2 boric acid, a little under 10% were dead, and the rest hatched. And that's pretty much where it stays. At 0.6, slightly less were dead and more hatched, but I mean, it seems like after 1.0 grams, the dead rate of eggs went up a little bit, which is interesting. I think it is 0.2 grams per liter, I believe. That's what this G/L means. No? Bomba said, my bad, Vivid 3. Smart person said, that would be UVA/UVB. A little isn't a problem. I found my fish sparkle better with it. Apparently it's also used for arowana tanning. I don't know about that. No, I've heard about fish tanning is a thing. Ooh, check it out, by the way. I got the phone on the tank with Galaris fry in it. They're getting a little... Some of them are getting kind of chunky, man. There's one right there in the Altherna Renecki. Mick said big difference between 0.0 and 0.2. Yeah, there's a big difference. I mean, it's from 35% down to under 10. And then again, it looks like at 1 gram a liter. And always double check what I'm saying, because when it comes to measurements and stuff, that's something I could easily fuck up. But I think that's what it is. But at 1.1, that is, it seems like slightly more dead eggs from 1.2 to 1.4, but still way more hatched than with no boric acid. Then we have the intermittent exposure of boric acid prevents the spread of infection to fertilized eggs. So they wanted to check if intermittent treatment would also prevent the spread of infection from dead eggs to live ones, and they used the boric acid concentration that 1, 2, 3, or 4 grams per liter exposure was for 4 hours once a day. Many eggs in the non-treated control group died as they were colonized by Saprolegina and Mycelia. Microscopically characteristic Saprolegina zoosporangia were observed with the release of motile zoospores. No hyphal attachment between infected and live eggs were observed at any of the concentrations tested. Dead eggs that were used as a source of infection showed scanty attachment of mycelium. They examined microscopically. Only remnants of mycelia mixed with some organic debris from the water were seen. And here we have another slide. So even intermittent treatment, it's looking like, was a success. Palm Puppy says UVB does not go through glass. There you go. See, this is why I love the chat so much. This is very good information that you guys are coming in saying. And this is another reason why, if I were to talk about something like that, I would definitely want to read up a little bit first. You know what I'm saying? Like, probably be a good idea, right? So 4-hour dip, that is correct. They did this every day for 14 days, was the intermittent testing with the boric acid concentration. So we have 0.0, 1.0, 2.0, 3.0, and 4.0. And at 0.0, we got almost 30% dead. At 1.0, which seems to be the amount recommended to me by Aaron. Jeffro says it works. Yeah, 1.0 only like, I don't know, 4%. At 2.0, maybe like a little under 10% dead eggs. The rest hatch. At 3.0, like 2% dead. So it's kind of seemed, before I was wondering if the higher concentration of boric acid was causing the more dead eggs, but it's kind of seeming like not. It maybe just like random infertile eggs or something, because we have 3.0's less dead eggs than 1.0 in this one. And then 4.0, there was about 10% dead eggs with the rest hatched. But still like a 20 to 29% reduction. Mick said we can all learn something new. That's what's great, indeed. Whew. Here we have the daily treatment. No hyphal growth was observed on any eggs in the treated group. No attachment. The percent was shown. Okay. So this is very similar. 0.0, 20% were dead. This is protection against infection of dead eggs. So here we get to the yolk sac fry, the protection of them against infection. It said significant reduction in yolk sac fry mortality rates were. This honestly I think is what's the most interesting, because we're maximizing the amounts of fry. The eggs is one part, right, and then there's a fry after. Now, if something that I don't know as much about is if the fry still have a significant risk of being infected with this kind of thing, and this seems to be more safe for them potentially than methylene blue, the fry that is, then that is kind of nice to have something that might help you reach more fry survival. So here we have a significant reduction in yolk sac fry mortality rates was observed in the boric acid treated group compared to the non-treated group. Dead yolk sac fry were completely covered with Saprolegina and Mycelia. Microscopical examination revealed tufts of white mycelia causing gill obstruction of live and freshly dead yolk sac fry in the non-treated control group. Here is the graph with the results of this experiment. So on the axis over here, we have the percent of live fry, and then we have the treated versus non-treated group up to 22 days. With the treated group at 22 days, it looks like a little under 90%, maybe like 87, 86% of the fry are alive. With the non-treated group at 20 days, about like 12% of the fry are alive. So that is a pretty significant difference there. Survival curve of the treated salmonoid yolk sac fry. Yeah, note the significant reduction in mortality among the treated group. In all experiences, the differences between the differences between the tested concentration and non-treated control group were significant in all the groups. Mick said, really smart person, arowana tanning. What the hell? Listen, man. Everyone needs to get a little tannin. Okay, in this study, we've shown for the first time that continuous or intermittent treatment with boric acid inhibits germination and colonization of Sapelogenia spores under laboratory conditions. The inhibition ranged from minimal to complete arrest of growth depending on the concentrations tested. We've also shown that boric acid is efficient at preventing infection of salmon eggs and yolk sac fry during natural and experimental infections. Boric acid is practically non-toxic to fish and aquatic invertebrates. This is always another question, right? How many of us, myself, have aquatic isopods in my egg tray? I have them on my egg tray, so I probably want to use something that's not going to kill them. Mix at 90% compared to 10%. Yep, I would call that significant. Beto said, I've seen arowanas go into tanks that were white, that's supposedly all white, that's supposed to bring out the color. Yeah, I know with Madaka, Captain's Critters, she talks about the ones being outside tanning, so I think it is a thing. It has a low bioaccumulation potential, so we got a reference here. And here's the thing, a lot of the boric acid references, as I've been going through this, are kind of old. There's a few that are recent, so it does seem like it's picking back up in interest, but like, there's nothing new under the sun, you know? Additionally, boron has been identified as a growth stimulator for embryonic rainbow trout, both in the presence and absence of several known essential elements. That effect was observed with a very low boron concentration, and they tested in like food for fish too. A similar effect of boron has been observed on zebrafish. Many reports have demonstrated the antimycotic activity of borate in controlling fungal and yeast infections in humans and plants. Under in vitro conditions, the germination and activity of Sapelogenia spores were inhibited with boric acid at 0.8 grams a liter. Further to this, the germination of Sapelogenia spores, bro, I don't know how to say this thing. I mean, I do, but like, something about it rolls off my brain. And the length of the developed germ tube were greatly reduced when boric acid were applied at lower concentrations, 0.5, 0.7 grams a liter. At similar concentrations above 0.6, the early developing Sapelogenia mycelia on sesame seeds did not show advanced growth, and 100% radial growth inhibition was recorded. We found it particularly interesting that boric acid controlled the spread of infection from dead, infected eggs over to live, eyed eggs when incubated together. The mycelia that covered the infected dead eggs used as a source of infection did not show expansive growth using an intermittent or continuous boric acid treatment regime, in contrast to non-treated controls. Moreover, following continuous treatment, the mycelia that covered dead eggs disappeared at the end of the treatment period, which would indicate the mycelium being killed. The effect was so distinct it was difficult to differentiate dead eggs used as an infection source and those that died during the experiment. So I anecdotally, again, I put a bunch of eggs into something, they all fungused. As a test, I put some boric acid in, and I definitely experienced this where all the dead eggs that had fungus on it, like it vanished. They were still there. If I look closely, I could see the little white thing that showed, that they're dead in the middle. But yeah. Nick said, if I'm correct, Dan's fish to the stream interviewing a specialist in or on boric acid. I wouldn't be surprised. It's possible. I did Dan's fish boric acid. Nothing popped up, but that's obviously a very broad thing. But this is something that people do know about and use, but it doesn't seem to be as well known as methylene blue. Moreover, following the continuous treatment, the mycelia that covered the eggs disappeared at the end. Yep. This is suggesting that continuous exposure to boric acid is able to kill Sapolegnia hyphae, but additional studies are needed to fully substantiate these findings. We found that the concentrations that we give optimal output range from 0.6 to 0.8 G/L, which I believe is grams a liter. We can also conclude that intermittent exposure to boric acid also had a very good effect on preventing the spread of infection. This to me is interesting because the other paper was looking at it for treating fish with disease. I kind of wonder about, short-term boric acid exposure. According to results and from the economical point of view, the best concentration to use is 1.0 G/L for 4 hours a day. All in all, this indicates that boric acid could be a good candidate for controlling infections of eggs and fish. Is alder cones a proven antifungal for eggs? Yeah. Alder cones, like tannins and stuff, is also very good and works well. When I went to Mitchell Broom's talk, he that's what he uses, and that's what I was using before. Would be like some leaves or tannins or something. But I think what's nice about something like boric acid is it's easier to repeat a specific concentration. With a powder, you can measure out per gallon. I actually haven't looked up Aaron just gave me a bunch of boric acid, which probably lasts me forever. He gave me like a little container. But I also looking at the cost and how long it'll last you is probably also pretty good. Because think about it, like methylene blue and leaves, like it's fine. Boric acid, you put a little bit of powder in there, and it's just good forever. It's very repeatable, and there's just not a lot. You know what I mean? There's just not a lot of variables going on. I don't like methylene blue. There's a lot of things I don't like about it. Like I said, I read some things that could harden some fish eggs. Maybe it's not as good for freshly hatched fry. This seems to not have those issues, and so far for me, I didn't even measure it. I just sprinkled some into the container, and it seems to keep things going. Beto said, would UV affect the tannins in water from having its medicinal properties? Someone correct me if I'm wrong. Does UV not break down tannins? I don't know. Nick said the dropping of pH is a big plus. Many bacteria can't survive in pH below 5.5. That is true. That's another reason why it works well. But Aaron said, I'm surprised how many people talk about leaves, methylene blue, etc. with boric acid. I mean, I've never really used methylene blue. It just never appealed to me. So I was always team like leaves and stuff, and that has worked. But also, it's very easy to put too many leaves and have too much tannins in the water. Like, I've killed a lot of isopods by putting too many leaves in there. So that's another thing that I like about the boric acid is potentially it's a bit more repeatable. You know what I mean? A bit more safely repeatable to get an exact amount. Okay. As we've shown here, boric acid prevents the development of Sapolegnia. Consequently, no spores release were detected when boric acid was applied at this stage. Pond Puppy says there's NFG, Neurofurstin green solution that contains meth blue. Yeah, I have heard of that. Another thing is some of these other things do affect like bacteria, like beneficial bacteria in the cycle and stuff like that. So that's another consideration. Boric acid does not kill the spores or hyphae immediately, and we base this on the fact that some fully mature zoosporangia showed spore release shortly after boric acid application. The observation that some spores slash zoosporangia treated with boric acid germinated slash exhibited spore release after replacing treatment indicates a fungus static rather than fungicidal activity of boric acid at the concentration tested. As regards the effect of boric acid on the mycelium infected dead eggs used as a source of infection, the efficacy was positively correlated with the boric acid concentrations tested. It is of importance that at high concentrations, 2.0 to 4.0, the hatchability, viability, and hatching time were not different from what was found at lower concentrations tested, 1.0. Moreover, no defects, morphological, or behavioral abnormalities were observed in a newly hatched yolk sac fry. This indicates that boric acid has a broad therapeutic window and is safe for use in eggs at such concentrations. Mick said, here in the EU, some of the older meds are banned now, but 100% not sure of which ones. That's another thing, too, is in some countries it's a lot harder to get different things. So, you know, I think boric acid is a pretty widely available thing. But we'll have to see. Sapulogenia hyphal structure was completely lost in mycelium on the treated dead eggs. Use it sort of. Okay, when boric acid were used at 0.5, mortalities were reduced from 90% in the untreated water control group to 17% in the treated one. The low mortalities recorded in the group in the absence of gross abnormalities following long time exposure indicates that boric acid is safe for use in salmon yolk sac fry at this concentration. I'm linking this article in the chat one more time, just in case you guys didn't get it, if you want to check it out yourself. But in conclusion, from the present study, we conclude that boric acid has a potential as a prophylactic measure and also a potential as a curative intervention against Sapulogenia infection and fertilized eggs and yolk sac fry of Atlantic salmon and possibly other species. Due to the high hatchability and survival rates recorded after the treatment, boric acid is considered safe for use in salmon eggs and yolk sac fry. However, further investigations on boric acid as a prophylactic treatment during an outbreak of Sapulogenia infection at production scale should be performed. Bam! Palm Puppy says the medications banned are probably all the ones Joe Rogan takes. Hilarious. What do you guys think? We finished our main boric acid paper. I felt like it took a long time. My apologies. That was the main one. I feel like just dumping boric acid into everything now. Let's go. I'm kind of curious about treating fish with it. I kind of wonder, or like just putting it in an aquarium's water, like just generally. Why not? It seems safe. I might just try it. Okay. Well, here's one thing that I wanted to look at as far as methylene blue. Methylene blue, this is from January 2025. This is from 2025, January 25. Palm Puppy says you're scared of it. Wait, what are you scared of? Bella says seems to work and for infections. Yeah. I kind of want to just try it on a sick fish, you know? But I don't want to make a fish sick just to test it. But like, I'm ready for science. You know what I mean? It feels like just as much of an experiment as just treating a fish normally as I always do. You know what I mean? You never really know. It's okay, Nick. You can get us started. Just can't read through every article done. We can go deeper ourselves. There we go. So this is one I saw pop up about methylene blue I thought would be interesting. Methylene blue at recommended concentrations alters metabolism in early zebrafish development. Okay, so methylene blue, antifungal agent, widely used during critical stages of zebrafish development. Most guidelines recommend 0.00005 or 0.0001% of methylene blue for embryo/larval rearing. Okay. The Organization for Economic Cooperation and Development zebrafish embryo toxicity test guidelines omits methylene blue recommendations, leading to inconsistent methylene blue use in zebra research. Why did I pick this? No, I'm not picking it just to use methylene blue to make it look bad, but I thought it was interesting because some of the strengths I saw in the boric acid thing was like, it seems like this is a clear dosage, and then I was looking around, I was like, oh, there's a lack of clear dosage guidelines on methylene blue use with zebrafish, which is like one of the most common fish used in research. I just thought was kind of interesting. But yeah, apparently the Organization for Economic Cooperation and Development zebrafish embryo toxicity test guideline omits methylene blue recommendations, leading to inconsistent methylene blue use in zebrafish research. Because methylene blue affects oxidative energy metabolism in vitro and in vivo, we investigate possible metabolic effects of methylene blue concentrations in developing zebrafish 1 to 5 days post-fertilization. Methylene blue increases the O2 consumption rate at 1 dpf, followed by an overall reduction in oxidative energy metabolism in post-hatch eleotherate embryos. And let's get into this, okay? And I appreciate you, Mick. I do the best that I can. Zebrafish are a widely used research model in many domains of biology, characterized by easy maintenance, high fecundity, capacity for high throughput screening, rapid development of translucent embryos, and genetic traceability. Okay, they've been a research model in developmental biology and genetics for more than 40 years. Due to their versatility, it's no surprise that zebrafish have become a central model to many disciplines, including but not limited to fish biology and comparative physiology, developmental biology, genetics, evolution, biomedical research, and increasingly ecotoxicology. Okay, so let's see what's going on here. Oh, a bunch of my lights just turned off. It shocked me. Compared to long-standing mammalian research models, several aspects of zebrafish husbandry remained less characterized. At early life stages of zebrafish are increasingly utilized for high-throughput pharmaceutical screening. What's up, Steve? How's it going? Woo! As a new approach methodology for regulatory toxicology testing, efforts to standardize guidelines for zebrafish rearing protocols have become a focus in the field, especially amidst concerns surrounding reproducibility in science. Originally developed as a dye in the late 1800s, methylene blue is widely recommended for use in zebrafish husbandry as a component of zebrafish embryo medium due to its antifungal activity. However, guidelines regarding its usage vary across different scientific organizations. For instance, the Canadian Council of Animal Care, CCAC, guidelines for zebrafish currently recommend the use of 0.00005% methylene blue in E3 medium. Similarly, a review of the European Union guidelines suggests the same concentration for embryos prior to exogenous feedings and transfer to a larger housing system. Along the same lines, the United States Spring Harbor CSH protocols recommend the use of methylene blue, albeit at a twofold higher concentration of 0.0001% methylene blue. On the contrary, neither the Organization for Economic Cooperation and Development, OECD, Fish Acute Embryo Toxicity Test Guidelines, the 8th edition of the Guide for the Care and Use of Laboratory Animals by the National Research Council, nor the 4th edition of the Zebrafish book mention the use of methylene blue. Oh, man. Pom Puppy says, is boric acid safe for inverts like isopods? I don't know if methylene blue is. Boric acid has been, I've been using it with them for a while, and Aaron is. And in the paper we just read, it says it should be safe. What's up? Holly Gibbs 627 said Steve with a peace sign. Let's go. Mick said, if I remember correctly, methylene blue or malachite green slows down almost all development in cells, so fungus will take a longer time to start and kill the fertilized eggs, but heavy dose will also slow down or kill the embryo. This is one of the main things that made me not want to use it and just do leaves. But this is kind of crazy to me. Like, they just listed like 5 major books on zebrafish specifically, or like laboratory animals, that do not detail the use of methylene blue, which is kind of wild. What's up, JP? Isopod agenda, let's go. Interestingly, in its addition to disinfectant, antibacterial and antifungal properties in aquatic husbandry, metabolic effects of methylene blue have been reported for almost 100 years. For example, increased oxygen consumption in tumor tissues and erythrocytes in vitro has been reported following methylene blue application at concentrations of 0.0005% as early as the 1930s. Okay. Serum, has been used to treat cyanide poisoning. Characterized by its inhibition of the electron transport chain via non-competitive bindings to complex IV. Methylene blue, due to its described action on the mitochondria, furthermore investigated as a potential treatment for aging or neurodegeneration, has been shown to mitigate pesticide effects on mitochondria and wildlife such as bumblebees. Despite the long-known metabolic effects of methylene blue, it's unknown what currently recommended methylene blue concentrations affect early zebrafish metabolism, and thus it may act as a widespread confound in experimental approaches using early zebrafish. The last thing you want to do is probably lower the metabolism of a fish fry or egg. Mick said, chems and meds are so interesting but scary at the same time. Very true. The few studies, Yep. To test this hypothesis, we are here to test the hypothesis that currently recommend methylene blue concentrations. They're testing that the currently recommended methylene blue concentrations exert repeatable and significant effects on early developing zebrafish metabolism and energy balance. To test this hypothesis, we use described zebrafish adapted metabolic assays at the organism level and targeted metabolic gene expression analysis at the molecular level. Because zebrafish adapted medium-high throughput metabolic assays, such as the Alamar Blue assay, are based on oxidation reduction dependent spectrophotometry, we secondarily also test the hypothesis that methylene blue at the recommended concentrations can directly interfere with the Alamar Blue zebrafish specific metabolic assays. And Mick says, correct dosing is important. Yes. And that's the thing that stands out the most when I was looking up the methylene blue stuff. Is just doesn't seem to be a big consensus on the safe concentration, which just goes to show you that that's why it scares me when I see 0.00005% of anything, and I'm like, and they're like, yeah, this is making things go bad. I'm like, oh my gosh. Beto says, I recently used malachite green, and even with daily water changes, the water started to sink. Yeah, be careful using that kind of stuff, man. All this stuff is like, we kind of take for granted some of the stuff we expose ourselves to. Definitely don't be drinking it. Holy! All right, let's get into it. So, development or exposure to methylene blue at concentrations recommended by the CCAC and the Federation of European Laboratory Animal Science Associations, as well as this 0.00005%, and the CASH protocols 0.0001%, were assessed and modified seahorse assay for zebrafish embryos. Both methylene blue concentrations significantly increased the basal OCR in 1 DPF zebrafish embryos compared to the control. For the CCAC, that's the 0.0005% recommended methylene blue concentration. This OCR increase was coupled to the increased ATP production compared to controls, while the CSH 0.0001% recommended methylene blue concentration had a significant reduction in spare respiratory capacity compared to the control. Furthermore, in control larvae, a significantly positive relationship between basal and maximal OCR was found, which was no longer present in methylene blue exposed embryos. So this is not looking good. Nick said, speaking of, I want to dose myself with some sugar right now. Holly Gibbs said, I'm a non-chem OG. You with the alder cone squad. The smart person said, reminder, 0.0001% is just 1 parts per million if I'm doing the math right. Listen, that's your name is smart person, so I'm gonna have to take your word for it. Mick said, Beto, perhaps the malachite green killed the bacteria. Dead bacteria can stink, good and bad bacteria. Well, that's another thing with some of the dyes is they can affect the positive, the beneficial bacteria, as we've said. But yeah, this sounds bad. Yeah, in control, the significantly positive relationship between basal and maximum OCR was found, which is no longer present in methylene blues exposed embryos. Significant positive relationships between basal respiration and ATP linked OCR were found in controls and embryos exposed to the CCAC 0.00005% recommended, but not the CSH 0.0001% methylene blue concentration. In a replicate experiment, methylene blue exposure at the CCAC recommended concentrations confirmed the increase in OCR reduction and in spare capacity at 1 dpf. So the CCAC, I think they said is two. I think the 0.005% one is a lot less than the the 3 zeros to the 1%, 0.001% one. So that one things weren't as bad with, it seems. In line with the increase in OCR, zebrafish at 2 dpf showed a significant and repeatable increase in larval surface layer after exposure to CCAC, CSH, and the 0.0003% methylene blue concentrations compared to the control. Mick said, I rarely use med products for my fish. Very rarely. Okay. Wise Mick. So here we have the graph. Methylene blue increases basal OCR. And mitochondrial membrane potential in 1 and 2 dpf zebrafish embryos. We have a chart here. It's not in a great resolution, so I'm having a hard time zooming in on it. But you can see they have a picture of the embryos at the different concentrations. It's just hard to tell the difference with the resolution of the graph here. Okay. Following the observed change in the basal OCR, when's the first time they mentioned OCR? Okay, let me not get distracted. My bad. Okay, following the changes in the OCR 1 dpf zebrafish, we conducted an indirect zebrafish energy expenditure assay using Alma Blue at different stages of zebrafish development. All embryos and larvae were washed 3 times prior to incubation with Alma Blue reagent. While oxidative metabolism-based energy expenditure was not affected in the CCAC, CSH, and higher concentration recommended by Chamber et al., when compared to controls after the first 48 hours of exposure, the highest tested concentration of methylene blue, 0.001%, significantly decreased oxidative metabolism-based energy expenditure irrespective of incubation time. Under standard embryo/larval zebrafish rearing protocol, zebrafish are kept in embryo E3 media containing methylene blue until 5 dpf before being transferred to system water. We therefore tested to see if longer exposure to methylene blue exerts significant effects on zebrafish oxidative metabolism-dependent energy. Zebrafish exposed to the recommended and higher concentration of methylene blue significantly and consistently exhibited decreased oxidative metabolism-related energy expenditure compared to controls measured at 24 hours and 48 hours. To determine whether reductions in oxidative metabolism-dependent energy expenditure observed at 5 dpf are dependent on preceding continuous 4-day steady-state renewal exposure window or can be elicited by acute post-hatching exposure alone, we conducted a 1-day acute and short-term methylene blue exposure at 3 dpf and quantified oxidative metabolism-related energy expenditure quantified at 4 dpf. Zebrafish acutely exposed to methylene blue from 3 to 4 dpf also exhibited a significant decrease in Alma blue fluorescence at 24 hours. Beto said, yeah, Mick, right now I have a tank of fish that are flashing, so I've been aggressively doing water changes, but I think I'm going to have to medicate. It's all the fish at this point. It's unfortunate when that happens. I've definitely been there. I think I finally got things under control. This one, a while ago, the tank with all the barbs were flashing a lot for a bit, and I just did like a water change every day. And eventually I did mix in some like methylene, sorry, not methylene blue, some Ikex with like a little bit of salt for a week. That seemed to make things better. But you never know. I need someone with a microscope near me to, next time a fish dies, I really want someone to go through it and tell me what they find. Because I have all my theories. I always have my theories, but I want to be able to know for sure next time. Or one day, I'll have the money to bust down a fancy microscope. Jacob said I have calamus right now. That does suck. The only thing nice about calamus is they're one of the cheapest things to treat because you can get the levamisole HCI from Tractor Supply. You get like a lifetime supply of that shit. And it just works. Stephen P put me onto a USB pocket microscope that works well. All right. Can you see all the protozoans and shit on that? I might have to just bust it down. See, the thing is, I want to get one that I gotta do my research for exactly what I need and exactly what I'd actually be able to use consistently with how lazy I am. All right. Methylene blue down regulates. Jacob said I got the Fritz meds on the way. Nice. Methylene blue down regulates multiple mitochondrial respiratory complex gene expression in 1 and 4 DPF zebrafish larvae. To assess the effects of developmental methylene blue exposure and mitochondrial respiratory complex gene expression at the CCAC recommended concentration 0.00005% and 1 and 4 DPF zebrafish were sampled. At 1 DPF, the methylene blue exposed group exhibited a significant decrease in the relative abundance of mitochondrial respiratory complex transcripts, SCHDA, P equals 0.0032. Oh, yeah, I know what that means. When compared to the controls. Similarly, the 4 DPF methylene blue exposed zebrafish larvae exhibited a significant decrease in the relative abundance of transcripts of mitochondrial complex genes. So all the people that understand this. I'm going to link this thing, and I'm linking this in the chat again. But all this this genealogy and stuff, I'm not going to be able to make heads or tails out of it. But I do understand a photo. And we see control. And we see 0.0005%, 0.001%, and 0.003%. I think they're looking for some fluorescence, some blue. And you can definitely see some blue spots in here with the varying concentrations. The developmental exposure of zebrafish to methylene blue at the CSH recommended concentration induced early hatching at 2 DPF. Furthermore, because we observed a consistent reduction in relative transcript abundance of genes linked to endocrine stress axis function, including STAR, the rate-limiting mitochondrial cholesterol import protein important in regulating steroidogenesis, and PCK1, a known cortisol-responsive gluconeogenesis enzyme, at 1 and 4 DPF exposed to 0.0005% methylene blue, we directly assess whether developmental methylene blue exposure disrupts the endocrine stress. To this end, we subjected the zebrafish larvae exposed to the CCAC recommended concentration to a swirling stressor test and quantified a whole body cortisol concentrations over time. While a significant effect of post-stressor time on cortisol levels were observed, known main methylene blue treatment or methylene blue treatment effect over time were found. Easy Schmeezy said, great talk, finished work. Fish work. So now it's time to bounce. Night all. Yo, Aaron used us to get him through his tasks, and now that's all done, he's just ditching us. Can you believe it? No, glad we're able to be here for you in your time of need. Have a good night, my friend. Okay, discussion. Please, no more numbers. Please. We're here to show that developmental exposure to methylene blue at concentrations and durations widely recommended in zebrafish husbandry guidelines and used in zebrafish research causes acute and robust organismal metabolic changes in developing zebrafish embryos. Though these changes coincide with in vivo increases in mitochondrial membrane potential and significant reduction of key transcripts associated with the mitochondrial respiratory complex and cytoplasmic metabolic pathways. Together, these findings show that methylene blue affects oxidative metabolism in zebrafish embryos consistent with the compound's reported mode of action in other in vitro and in vivo models. We further report that methylene blue as a redox agent has the potential to confound an increasingly used high-throughput zebrafish metabolic phenotyping assay, the Almer Blue assay. So we're going to have to, a couple things going for this. We're going to have to look at the effect of tannins and compare that, because I feel like that's the trio. I feel like everyone in the chat, no one really uses boric acid, but some people use methylene blue, but most people like use in older clones and stuff. So we got to look at tannins at a future date, just to have the trio comparison, but also I need to look at this Almer Blue assay thing, figure out what the hell that actually is. Mix at MIO with soft water, doing water changes, dilute water from salt, sometimes in MIO with soft water, doing water changes, dilute water from salt, sometimes then resulting in fish getting weaker, osmotic regulation in the fish body. I think, are you saying that, because if you're saying what I think you're saying, sometimes I think about my soft water and I'm like, maybe there's some minerals and stuff that would be helpful for the fish immune system that they're missing out on, that I need to put extra care in their diet. Or I still sometimes sprinkle like a little bit of marine salt in a few different tanks for that reason. I think that's what you're talking about, but I'm not sure. You just didn't put enough dots in your message for me, dot, dot, dot. I need like 3 dots. You always do 2 dots. Like, what's going on here? How am I supposed to understand the message? Developmental exposure of zebrafish embryos to recommended methylene blue concentration resulted in visible blue stains in the larval head, mouth, and olfactory epithelial area at a higher concentration throughout the whole body. Yeah, that's the thing. Like, again, boric acid versus methylene blue, like, whatever. But, like, when you look at the photo and you just see the fish, like, its body is dyed blue, there's no way in hell that is not bad. You know what I mean? Like, can you imagine if your baby was blue for any reason? You'd probably be like, man, whatever's making my baby blue, like, this probably is not good for no shit. It's bad for the respiratory health or whatever. Like, I don't know. Methylene blue concentrations resulted in visible blue stains in the larval head, mouth, and olfactory epithelial area, and a higher concentration throughout the whole body. Indeed, studies have reported zebrafish exposed to methylene blue across multiple development stages revealed a dose and time-dependent increase in methylene blue intake. Initial intake resulted in low embryo concentrations as early as 3 HPF, which increases the embryo concentration similar to medium by 15 HPF. This is in line with high biodistribution reported for methylene blue in other in vivo models, indicating its mobility across cell membranes, and a reported plasma half-life of 5 to 6.5 hours in rats. Taken together, the chorion does not seem to act as an effective barrier to methylene blue, but additional routes other than diffusion likely differentially affect and possibly accelerate the uptake kinetics of methylene blue after hatching. Mick said, small water change is good, but large ones when having ill fish. Large water changes can shock the fish, benefiting bacteria and parasites to keep them thriving. Okay. Yeah. Sometimes I do wonder, yeah, I should be careful to make sure I'm not doing too big water changes. I don't think I usually am, but yeah, I see what you're saying. Especially like you said, having soft water. If I haven't done one in a while, things have built up from me feeding and stuff like that, so it's a bigger swing of parameters. It's like when you're cutting stuff with RO water, Lick phylactery said oxygen. Yeah. Oxygen in the chat. Let's go. Sorry. Palm Puppy said the blue fish group. Yeah. Oh, here we go. Oxygen's in the next line. And in line with uptake through the chorion, we observed repeatable methylene blue dependent increases in oxygen consumption rate. That's what OCR is. In unhatched 1 DPF embryos, which were linked to ATP generation. An in vivo mitochondrial mode of action of methylene blue exposure at recommended husbandry concentrations were further corroborated by an increase in mitochondrial membrane potential assessed using a waterborne JC10 probe at 2 DPF. What the hell is it? I gotta look up what the symbol means. Okay, mitochondrial membrane potential. It's got a fancy symbol. Okay, this looks like some occult shit. I'm not gonna lie. A hider like I had to double check. Like, what the hell? How do they even make those numbers on the thing? Okay, a higher mitochondrial membrane potential is associated with increased efficiency of the electron transport chain. It may subsequently promote oxidative phosphorylation. Indeed, several studies have reported the capacity of methylene blue to increase internal respiration both in vivo and in vitro. The capacity of methylene blue to increase the oxygen consumption rate was initially reported nearly a century ago, where methylene blue was shown to increase the oxygen consumption in leukocytes in tumor tissue. More recently, studies have reported the oxygen consumption rate stimulating effects of low doses of methylene blue in CNS, in which it readily accumulates by crossing the blood-brain barrier. Oh, well, that sounds scary. As well as diabetic hearts and hepatocytes. Okay. Given the unique redox potential, methylene blue enables the direct transfer of electrons to cytochrome C to enhance mitochondrial respiration in several mode systems. It is feasible to assume a conserved complex specific mode of action in developing zebrafish embryos based on the evidence presented. Jacob said ATPs are cool. They're like batteries to the cell. They transport energy through the polysaccharide chains or any chain of molecules. Mick said that's why the instructions on fish meds need to be followed. I believe many of us cheat with the work after dosing for a while according to the instruction. Mick calling us out. Okay. Okay. Sorry, I'm just like, I'm kind of like scanning through. Okay. I want to see what they found. Oh, yeah. Finally, we observed that the CSH concentration, 0.0001%, of methylene blue induces early hatching. Previous studies reported conflicting results regarding the effect of methylene blue exposure on hatching. While chemical exposure-dependent alterations in hatching time have been reported as an endpoint in zebrafish toxicity testing, further studies should investigate possible interactive effects of methylene blue and test chemicals on this endpoint in toxicity screening studies. In light of the fact that the telos endocrine stress axis end product cortisol have demonstrable effects on zebrafish development and metabolism, we directly probe possible effects of methylene blue on the acute stress response. We quantified the activity of endocrine stress axis at baseline in response to acute stressor. However, developmental methylene blue exposure did not affect cortisol response over time as tested in a two-way ANOVA. Thus, we concluded that mitochondrial effects of developmental methylene blue exposure were metabolic in nature and did not extend to the differences in cortisol production and thus the endocrine stress axis function. Overall, methylene blue exposure at recommended CCAC, FELASA, and CSH guidelines induces robust metabolic effects linked to mitochondrial function. These effects are in line with the reported mode of action in methylene blue and mammalian model systems. Compared to previous studies investigating the effects of methylene blue exposure on more general aspects of zebrafish development, these previously unmeasured, mode of action-based, robust, and repeatable metabolic effects occur at exposure concentrations currently recommended and widely applied in zebrafish husbandry protocols. This is problematic because zebrafish are, due to their long-standing use as developmental model, their genetic traceability, their potential for high-throughput applications, and their exemption from vertebrate model animal ethics regulation in the Eleuthero embryo stage before initiation of exogenous feeding in several legislations, a widely increasingly used research model. Oh man, Oh, that is a good point. That would be really like they're using them to test all sorts of medicines and stuff. If methylene blue is having a significant effect on this function, that could call into question the accuracy of some results, right? I could definitely see that being an issue, especially since there's not seem to be an agreed upon concentration. As such, this versatile zebrafish model has and continues to contribute to significant advances in comparable physiology, biomedical sciences, and toxicology. While caution regarding the use of methylene blue in zebrafish research is thus generally warranted to avoid currently underappreciated confounds on measured endpoints, the efficacy of methylene blue as a therapeutic compound may be specifically tested in this model. Indeed, methylene blue has been investigated as a potential therapeutic due to its neuroprotective properties, as zebrafish are increasingly recognized as a valuable biomedical research model organism to study therapeutic compounds and their mechanisms. This model may be effectively utilized to evaluate the potential benefits of methylene blue. All right. Let me read the conclusion part. I'm putting the link to the full thing again in the chat. Please feel free to check it out. But in conclusion, we demonstrated that methylene blue exposure embryo larval zebrafish at widely recommended concentrations robustly and repeatedly affected several organismal and molecular components of oxidative energy metabolism. Methylene blue, furthermore, has the potential to confound redox reaction dependent high throughput assays of energy expenditure. The impairment of oxidative energy metabolism in developing zebrafish is mediated, at least in part, through methylene blue-induced mitochondrial dysfunction, in line with the known mode of action of methylene blue in other model systems. Due to its unintended consequences in developing zebrafish larvae and its strong potential to confound metabolic endpoints, researchers should reconsider methylene blue use as an antifungal agent in zebrafish research. Okay, I put the link to that in the chat. That is our two main papers to read through related to boric acid and methylene blue. Shout out to everyone active in the chat. And if you're in the replay crew or you're lurking, feel free at some point to let me know what you think. But I don't know. I've been using boric acid. It's been nice. I've avoided using methylene blue too much. Yo, my thing just popped up saying, do you want to switch it to a members only live stream? This is devious. YouTube wants me to go to members only. This is crazy. Guys, I can't believe it. But yeah, let me know what you guys think. I'm hoping to stream tomorrow. I'm hoping to stream Thursday. I'm hoping to be streaming with Corey. I think we know what we're going to talk about, but you can always bring whatever questions you have. I'm sure we'll get distracted by the chat. Tomorrow, I'm not 100% sure what I'm going to go over, but it might be some new stuff. We'll have to see. But yeah, I'm not gonna overstay my welcome on this stream. Mick said I'll be lurking. I'm gonna head out. We did do 2 hours. We did our job here. We did a quick 2-hour stream. Hopefully this was enough to get done whatever you're working on. But I'm gonna hit the hay so I can keep going. Hopefully be back tomorrow. I think Mexicali's having a pretty good stream tomorrow. I think. Let me see. Mexicali Fish Keeper. I think I got a stream because I actually want to watch this stream. So, okay, 10 p.m. March 4th, 10 p.m. Mexicali Fish Keeper, Amazon Research Center for Ornamental Fish. Pretty cool. I'll put the link to that. I'm gonna be watching this, so I gotta stream before this or I gotta stream after this. Probably gonna be before this. So before 10 p.m. tomorrow, I'll do my stream because I want to watch Jorge's. But yeah, let me know what you guys thought. Did a little quick one. Did a little bit of reading. Hopefully, it's something interesting. I've been using boric acid. Maybe I'll do a little bit of my own, experiment. See what I can show with it. But yeah, I'm gonna head out. Holy. Anything else? Any questions? Questions, comments, or concerns? Anything on your guys' mind while I'm still here? Anything? We're good. Pom Puppy says, "Live long and prosper." Ada the cat is now telling me it's time to get off stream. She came to say hi to me. That usually means I've been streaming too long. Ha 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 ha. I have kidnapped you, Ada. In fact, I have catnapped you. You cannot escape. Okay, you can escape. She always wants to jump on me, but then when I pick her up, it's a problem. But if I don't let her sit in my lap, then it's a problem. It's gotta be her. Like, see? She wants to jump up onto my lap. You can tell. But see, if I pick her up, it's just not, she don't like it. She wants to do it her way. Come on up, Ada. Come on up. Look, I made a space for you. You can say hi to the stream. Yeah. Come on up. Come on. Ada. 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 There we go. Okay. What do you have to say to the stream? Everyone's waving. Everyone's saying goodnight, Ada. What do you have to say? That's it? That's all you have to say? What do you think about boric acid? Methylene blue? What do you think? You have an opinion? Kitty massage. Ada likes the full head massage, relaxation from that her brain been working too hard all day. She probably been reading about methylene blue. Don't you think? Yeah, probably. Boop, 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 boop. Okay, I'm headed out. Nick says, "Great as always, Nick. We need the knowledge." Appreciate you. Shout out to everyone in the chat. I always appreciate when you help me read through these, explaining things along the way that maybe I missed. Shout out Bomba, of course, came through in the chat. Mick, smart person, letting me know the calculations on the fly. Let's go. Aquatics, Jeffro, appreciate you stopping by in the chat. My man, my guy, my friend, my fish. My fish. Well, speaking of fish, Pond Puppies, shout out to you. Appreciate you holding it down in the chat. Easy Schmeezy, of course, stopping by only for what he's interested in and ditching us. Steve, Big Steve came through. Appreciate you, Big Steve. Holly Gibbs, I saw TGIF Fun Day coming through for a second. Appreciate you being through. Lich Phylactery came through just to say oxygen. I appreciate it. I'll keep that in mind. Jacob, of course, holding it down. Andre, of course, holding it down in the chat. A couple fish came in just to roast Bomba, which I always appreciate. I love when people are in the chat and they only show up just to, just to dunk on someone. I love that. Sage Cave of Wonders came through at the beginning. Fish NJ, yes, we did a nerdy stream today. Johnny Best, thank you again for the 5, my friend. Thanks for coming through. Pond Puppy says, "Cats domesticated, man." Look, Ada, you want to show him? Hey, touch. Hey, touch. Hey, touch. You gotta touch your nose to my finger. Oh, good girl. All right, Ada. All right, Ada, one more. All right, come over here. Ready? Ah, wait, not yet. Wait, Ada. I gotta get the camera angle on you. Okay, wait, you gotta stand up or else it doesn't count. Okay. Ada. 1 second. What's that over here? Over here. I'm trying to show him you sitting, but you're already sitting, so it doesn't really have the same effect. Okay, come over here. Okay, now Ada, sit. Oh my goodness, what a good cat. What a good cat. I'll have to get you some treats after this. And yeah, Maven, shout out to Maven. Beto, of course, coming through. Good luck with the Malachite Green. Cam Jam, thank you, ma'am. Also came in. And I think that covers everything. So yeah, I'll see you guys. Love, peace, chicken grease. This has been In My Tanks. I'm blue. Dabba dee, dabba die. Dabba dee, dabba die. Dabba dee, dabba die. And I'm out. Holy.